Hi everyone, welcome back to A+ Maths. My name's Heidi. How are you going today? Today I'd like to do odd and even functions. So, what are odd and even functions? Well, an even function is something that we see all the time in real life. It's symmetry. And you would have studied symmetry early on in primary and even in kindergarten when you used to do those arts and crafts where you paint on one side, then you fold the piece of paper in half, and then you open it, and then you have a symmetrical picture of usually a butterfly. Let's have a look at how we do that now with graphing. So we need to be able to tell if a graph is odd, even, or neither. And there are some basic rules that we need to follow. So we have an even function or an odd function. Even functions have the rule f of x equals f of minus x. And odd functions have the rule f of x equals minus f of minus x. What does that actually mean? Well, for an even function, it means it's flipped about the y-axis. And for an odd function, it means it's flipped about the y-axis and it's flipped about the x-axis. So let's have a look at some of those times where we actually see this in real life. So for example, you would already know the Taj Mahal in India, of course. Take a look at how symmetrical that is about the y-axis in the middle. And of course we have the Eiffel Tower in France, Paris. It also has symmetry about the y-axis. Those two architectural buildings are both even functions. What other places do we know? Here we have the Great Chapel in South Africa. It's an amazing piece of architecture and it's also an even function. And the Chambord Castle in France. So over many hundreds of years, different architecture has been based on symmetry. And of course we have the Strasbourg Cathedral in France and our very own Sydney Harbour Bridge in Australia. You can see that they're all symmetrical about the y-axis. We also have symmetry in nature. Take a look at the beetle, the butterfly, the leaf, or a starfish, or a beautiful flower. All of these things have symmetry about the vertical y-axis. Let's say we have a graph and we want to find out if it's an even function. Remember, what does that mean? What's our rule? F of x equals f of minus x. We need to see if it's been flipped about the y-axis, or we need to flip it about the y-axis to make it an even function. So let's say we have a graph that looks like this. If we flip that about the y-axis, then we have this graph, and now it's an even function. Let's take a look at another one. Let's have a look and see if this is an even function. Let's say we have this shape. If we flip that about the y-axis, what do we get? Great. Did you think about that? We get that shape. What about this one? What's that going to look like if we flip it about the y-axis? Think about it. What did you get? Did you get the same as me, the red graph? Good job. Let's take a quick look at two more. There's a nice little cubic wavy graph. What will that look like if I flip it about the y-axis? Great. Did you get that too? And if we have a graph like this and we flip it about the y-axis? Great. Make sure that your y-intercepts stay the same. Now let's figure out a way that we can actually find, is a function even or not? Let's say we have the function f of x equals 2x squared minus x. So we need to first find f of minus x. If we have f of minus x, that means that wherever there's an x, I'm going to replace it with minus x. Don't forget to use brackets, and that way we don't make a mistake. So we have 2 bracket minus x all squared minus bracket minus x. Now I want to simplify the brackets, so I get equals 2x squared, because minus x times minus x is plus x squared, and a minus is a plus, so I have plus x. Now we want to have a look. Is the first function, fx, the same as the bottom f of minus x? Are they the same? No. That means it's not an even function. Let's have a look at another one. Let's say we have f of x equals 1 all over 1 minus x squared. What do we do first? We find f of minus x. And what does that mean? It means wherever there's an x, I'm going to replace it in brackets with minus x. And that's what I've done in my next line. Then I need to simplify it. Don't forget that minus x times minus x is plus x squared. So I'm going to have 1 all over 1 minus x squared. Then we need to compare f of x with f of minus x. Are they the same? Are they exactly the same? Yes. Therefore, this must be an even function. Let's try another one. F of x equals x minus x cubed. Again, how do we start? We need to find f of minus x. And how do we do that? Wherever there's an x, you put brackets and you put a minus x instead. So bracket minus x, close brackets, minus, open brackets, minus x, close bracket, cubed. Then we use our next line to simplify it. So we have minus x minus x cubed, because minus x all cubed is minus x cubed. And then we simplify it further, in which case I get minus x plus x cubed, because a minus and a minus is a plus. And of course, what do we do now to show if it's an even function or not? We need to compare f of x with f of minus x. Are they the same? Are they exactly the same? No, because the x at the front, one is plus and one is minus, so they're not the same. Therefore, this is not an even function. Now let's take a look at odd functions. Odd functions are a little bit more tricky. Odd functions have the rule f of x equals minus f of minus x. It's a little bit trickier, but we're going to follow the same types of rules. Remember that an odd function is flipped about the y-axis and the x-axis. So it's a little bit trickier. Let's take a look at some different types of odd functions. So if we have a graph that looks like this, remember we need to flip it about the y-axis first, and then we need to flip it about the x-axis. And that's what it's going to look like. That's an odd function. Let's take a look at another one. So let's say I have this shape. Remember, I need to flip it about the y-axis first, and then I'm going to flip it up against the x-axis. And that's what that one will look like. Let's try some more. Now we want to know, are these functions odd? How can we tell? We know our rule, f of x equals minus f of minus x. So we're going to start these the same way that we did when we have an even function. Let's have a look at the first example. F of x equals x plus 3x squared. We're going to do the same thing as we did with even. So we need to find first f of minus x. And what do? Wherever there's an x, put brackets and replace it with minus x. Then we need to simplify it. And what do we get? Minus x plus 3x squared. So we now need to compare f of x with f of minus x. This is how I do every single one. So we're going to stick with the same pattern. Are they the same? No, because you have a plus x and a minus x at the front, so they're not the same. That means that they're not an even function. That means that we're going to keep going and see what happens if we take out a minus out the front of f of minus x. We are now going to factorize out a minus from our last line of working. And what do you get? If you factorize out a minus, you get minus, brackets, x minus 3x squared. Now I'd like you to have a look and see whether or not the first line f of x is the same as the bit inside the brackets here in our last line minus f of minus x. Are they the same? No, because one has a plus and one has a minus. Therefore, this is not an odd function. Let's take a look at another one so that you can try again and make sure that you understand what's going on. Don't worry, we're going to go through enough for you to get the idea at the end. Let's have a look. Is this function odd? F of x equals x minus x cubed. The first thing we need to do is to find f of minus x. Wherever there's an x, replace it with minus x. Then we're going to simplify what we have in the brackets. And we're left with f of minus x equals minus x minus minus x cubed, which makes it minus x plus x cubed. Now we need to have a look. Is f of x the same as f of minus x? Are they the same? No, the signs are different. So we know it's not an even function. So we can continue. Now we're going to check to see if it's an odd function. We need to take out a minus from our last line. We're going to find minus f of minus x. So factorize out a minus, and what do you get? Minus, bracket, x minus x cubed, close brackets. And again, we're going to compare what we have up the top for f of x with what we have inside the brackets that we just factorized. Are they the same? Yes. Therefore, we know that this function is an odd function. Hopefully, you're starting to have an idea of what's going on. Let's do another one to make sure. This time we have a fraction. F of x equals 2x all over 15 minus x squared. We always start the same way. F of minus x. Replace the x's with a minus x. Put brackets so that you don't get it wrong. And then simplify. And I'm left with minus 2x all over 15 minus x squared. So we need to look at the fx and our last line and think, are they the same? No, because one has a minus out the front and one doesn't. Therefore, it's not an even function. Now we have to check to see if it's an odd function. And how do we do that? We need to factorize out a minus. Now, when you factorize out a minus from a fraction, you can just take out the minus from the top, like this. And now we have a look to see whether or not our original function is the same as what we've got in front of the minus. Are they the same? Yes. Therefore, this is an odd function. I hope you all understand now how to prove if something is an even or an odd function. If it's not even and it's not odd, then of course it must be neither. Don't forget, it's not so difficult as long as you follow the rules. You always test for an even function first because that's the easiest thing to do. Find f of minus x by replacing the x with a minus x. Then, if it's not even, you factorize out a minus. And then you compare your f of x with whatever's in the brackets after your minus and see if those are the same. If they're the same, it's odd. If it's not even and it's not odd, then it must be neither. I hope you all understand. I look forward to seeing you again soon. Don't forget to like and subscribe. Bye.